All right, welcome back, you guys. So here we go, doing probability handout homework, I should say, for simulations and predictions. So if you don't have a piece of notebook paper by now, you should get a piece of notebook paper because there's not enough room to show your work here. And you should be pausing this video, trying them on your own, and then watching them. Then try the next one on your own, and then watch it, so that hopefully you are getting better at this, and you'll be able to do them on your own by the time you are done, if not from the start, okay? A fast food chain surveyed a random sample of students to determine what pizza they preferred. Cheese pizza was preferred by 40 students. Pepperoni pizza was preferred by 28 students. Based on the results, how many of the 340 students preferred cheese pizza? Okay, so you're going to notice that what I've done with my piece of paper is I've already folded it in half so I can have two columns, but it'll stay neat. I do want us to work on neatness. Remember, it's about showing the work, not just about getting the answer, so I want to see each step. So anything that goes on in your mind, please make sure you're writing it on paper and no calculators. So I'm going to label this on top, handout. Oh, I should have said homework. What does it? Handout 4. Homework, I think I'll say that. Okay. So we are looking at cheese pizza. So let's see, 40 students out of, we need to know the denominator. So 40 plus 28 is 68 of the people surveyed liked cheese pizza. So we're going to assume that this will be the same probability as the 340. That's how we're making our prediction anyway. So keep in mind that if we divided this out, we would have our number between 0 and 1 because probability is always a number between 0 and 1. Remember, 0 means no chance, 1 means it's absolutely going to happen. So I'm going to start by simplifying. You can simplify at the end. I just prefer to simplify before I multiply. Both of the numerators are even numbers and the denominator is also an even number. So I can pick one from the top and one from the bottom to simplify. I'm going to divide this by 2 and I'm also going to divide this one by 2. So that's 34. And again, I have a numerator that's even and a denominator that's even, so I can divide by 2. I'm going to go ahead and cut this in half. And that's 15, 16, 7. Cut this in half. Okay, so this is a prime number. So 17 does not go into 10. Does 17 go into 34? Well, 17 times 2. 2 times 7 is 14. 2 times 1 is 2, plus 1 more is 3. So 17 goes into 340. So 17 divided by 17 is 1. And 340 divided by 17 will be 20. Now I can go ahead and just multiply, and 20 times 10 is going to be 200. That will be our final answer. So come over here, and 200 is A. So all of the ones we're going to put in an A. What are we trying to figure out? What kind of meals do math teachers eat? I already know the answer to that because, of course, I'm a math teacher. All right. Skipping a line. I would rather you skip too many lines than not enough lines. I am concerned with your work. Please square off your answer so I can find your answer in all your work, okay? On the subway, 8 out of 11, so we should recognize that as our probability. People are carrying a briefcase, so that many people have a briefcase with them. Based on this information, if there are 700 people on the subway, about how many do not have a briefcase? All right, do not. These are very important words. Okay, so if 8 out of 11 have a briefcase, then the rest did not. So out of the 11, that would be 3 that do not have a briefcase, and that's the number we want to use. So over here, I'm going to say, all right, so 3/11 of the people do not have briefcases. So to make my prediction, I will say that out of the 700, 3 times 7 is 21. So that's 2,100. And 11 times 1 is 11. divide both of these. We have 2100 divided by 11, because we certainly wouldn't want to give that answer for a word problem. So 11 goes into 21 one times. Let's subtract our 11. We get 10. Oops, drop down our 0, add another 0. 11 goes into 100 9 times. Subtract our 99. We have a 1. Drop this down, and we have 10. And it goes in, no, it does not go into 10. And remainders are in the past. Let's leave those back in elementary school. We're either going to write this as a fraction or a decimal. Fractions are frankly very easy because with our remainder, that's just our numerator. And what we're dividing by is our denominator. Now we have to give this as a whole number since it's a word problem and what it's asking for. So I know that this number lies between 190 and 191 on a number line. If this is closer to 0, we're going to round down. If it's closer to 1, we're going to round up. This is most definitely closer to 1. So our answer will be 191. So looking for 191 here, and it looks like E is 191. So we have an E here and here. Now keep in mind, if you guess what kind of meals math teachers like to eat, you still have to do all the math problems. This is a math lesson, so we don't get to take shortcuts, okay? Number 3, pre-plan it by skipping that space. Suppose a coin is flipped 10,000 times. What is the reasonable prediction for the number of times the coin will land on tails? Well, we can use the theoretical probability of 1/2. So half of the times it should land on tails. So of the 10,000, let's do our math. Going to simplify beforehand, although some of you may already see the answer and don't need this step. But both of these are even, so I will divide them by 2. So that's 1. Cut this in half, and we have 5,000. And so that equals 5,000. And let's take a look. 5,000 is S. So 3's are S. All right, number 4. Now, if we have enough room, we can continue. If you ever feel like that's not going to be enough room, I'd rather you just go to the next column, just flip it over and start here if you don't feel like you have enough room. Okay. Number 4. On a youth soccer team, 3 out of 12, so there's our probability. Members have played in previous years. Based on this information, if 150 kids are on the youth soccer league, how many could be expected to have played the year before? So we still have played. It's important to note that those are the same things. Okay, so 3 out of 12 in our sampling had played. So out of 5, well, the 150, let's see how many we predict will have played. So I'm going to simplify first. Now, if we did this with a calculator, it would be very easy. We're not using a calculator. We're practicing our multiplication, our division. We're certainly practicing adding, subtracting, multiplying, and dividing fractions because I think we need a lot of work on that, okay? So please don't take that shortcut. Both of these are divisible by 3. So 3 divided by 3 is 1. 12 divided by 3 is 4. Now, both of these are even numbers. So 4 divided by 2 is 2, and 150 divided by 2 is 75. Now keep in mind, you might have simplified a different way, but we're going to get the same results at the end anyway. 1 times 75 is 75, and on the denominator we have 2. So we're going to go ahead and divide that out. 2 goes into 7 3 times, minus 6 is 1, drop down our 5. 2 goes into 15 7 times, so that's 14. Subtract, we get 1, and we will write our fraction here because we got to our decimal. Okay, so that number falls between 37 and 38. Now, 37.5 is exactly in the middle between 37 and 38. When things are exactly in the middle, we give them the benefit of the doubt and we round up, okay? So 38, and that would be right here, M, so number 4 is an M. Is that the only 4 we have? Okay, now remember I pre-folded it, so I have this nice line. I can just work down on this side, okay? So a box of 25 light bulbs is shipped to a hardware store. When it arrives, 4 of the bulbs are broken. So we ordered 25 light bulbs, let's see, and 4 of them were broken when they arrived. Okay. Predict the number of broken bulbs. So again, broken, so that's good. These are the match up. In an order of 125 bulbs. All right. So this is problem number 5. Also notice I'm circling the problem numbers because math is filled with numbers, and that way we know that this isn't a number that belongs in the math problem. Okay, so 4 out of 25, and we will use that probability to figure out how many will come broken out of 125 light bulbs. So I noticed that we have a numerator and a denominator that can both be divided by 25. So this will be 1, this will be 5, and that will give us 20. And the bottom number is a 1, so we don't need to write it. So let's take a look here. Do I see a 20? Oh no. Oh good, I do. Q. All right, 5 is a Q. All right. Number 6, the airport security randomly selects 36 suitcases from the security line. Of these bags, they screen 8 suitcases. So 8 of the 36 suitcases are screened. Based on this information, what is the most reasonable prediction for the number of suitcases that will be screened in a group of 180? So 8 out of 36 suitcases were screened, and that will help us predict the probability of 108 suitcases being screened. Again, I've got a lot of even numbers, so I know those are all divisible by 2, so I just need to pick 2 of them. I'm going to pick the 2 smaller ones. So half of 8 is 4, and half of 36 is 15, 16, 17, 18. I see an 18 and an 18, so I'm going to divide both of these by 18. 18 divided by 18 is 1, and 180 divided by 18 is 10. So my numerators multiplied together is 40, and my denominators are 1, so we don't need to do anything with that. So 40 for number 6 is L. All right, and number 7. In a game, the player wins if he rolls a 6 on a number cube. So if you win if you roll a 6 on a number cube. If the number cube is rolled 18 times, then what is a reasonable prediction for the number of unsuccessful rolls? Ooh, that means they lost. So if you have to roll a 1, or 6, I'm sorry, to win, there's only 1 6 on a number cube. So that's how many wins we have. If to win, we have 1 out of 6 chance. So how many times will we lose? Well, anytime we roll a 1, 2, 3, 4, 5, we lose. So that is 5 out of 6 times where we will lose. And that's the number of unsuccessful rolls. That's the number we want to use, okay? So 5 6 of the times will give us an unsuccessful outcome, and that's out of 18 times that we're going to do it. These are both divisible by 6, so 1 and 3, 5 times 3 is 15. So 15 out of the 18 times we predict we're going to lose. And that will be a U. Oh, I didn't do 8 yet, so that won't be an L. I'll switch it later. See what that should be. All right, and 8. A container of beads contains 8 red beads, 6 yellow beads, and 6 green beads. The beads will be drawn from the basket and replaced 60 times. It's important to know they're replaced because that means the odds are not changing, okay? What is a reasonable prediction for the number of times a red or green is drawn? All right, so notice too when I identify important information, I didn't underline the red beads, yellow beads. I could have, but my goal is to really identify the important numbers and quickly why they're important. And what I'm looking for, key information with as little information highlighted as possible. Because if you highlight too much when you're done, instead of making it easier on yourself, you're going to have a mess because you're going to have just so much highlighted and circled that you're not even going to be able to see the words, okay? So be careful, don't identify too many things. Just the important things, most important things. So green or red, let's see, there's 8 red and 6 green. So if there's 8 red, 6 green, I didn't mean to put that on a fraction. That is 14 red or green beads. And out of how many? That was 6, 6, 8, so 12 plus 8 is 20, so 20 in all, okay? So that means 14 out of the 20 will be either green or red. And we're going to do this 60 times. So 20 divided by 20 is 1, 60 divided by 20 is 3, and then 14 times 3, 4 times 3 is 12, 3 times 1 is 3, plus 1 is 4, and our denominator is just a 1. So 42, and 42 is an R, so 8 should really be an R. Make that an R. So what kind of meals do us math teachers like? Well, we like square meals, of course. All right, number 9. East Side Middle School has a 75% student participation in the Fall Carnival. Determine which of the situations below could model the probability of a student participating. 75%, I'm already thinking when I see 75, 3/4 is 75, and of course 3/4 out of 4/4 is a whole dollar. So I'm going to look for something that is representative of 3/4. So rolling a number cube, I already know is going to give us 6 sides. When rolling an odd number, and there are 3 odd numbers, represents a student participation? Well, no, because that's 1/2, and half is not the same as 3/4. So that one is not correct. Spinning a spinner with equal sections marked with the letters A through E. So let's draw this out. Here's my spinner. I have A, B, C, D, and E. Well, if I take a look at this, I have 2 of them that are vowels. That's 2, but those are 5 spots. That's not the same thing. Spinning a spinner with 4 equal sections. That's important. I needed 4 equal sections. We're spinning anything but a 1 represents the students who participate. Okay, anything but a 1. So if I have 1, 2, 3, and 4, 2, 3, and 4 would be not a 1, and that would be 3 out of 4. So that works. That's 10. A PE teacher divides the class evenly for a game of kickball. If the likelihood of being on Team Eagles or Team Jaguars is the same, that would give us a 50-50 chance, right? Describe a simulation that could represent the team's assignment for the next 10 students in the PE class. So I'm going to flip a coin, and I will do this 10 times to represent each of the 10 students. And last but not least, 11, there is a 10% chance of rain. A spinner with 10 sections is spun to simulate the probability of rain. So 1 out of the 10. That looks good. So that represents the probability of rain. We are spinning a 1 indicates the rain. Okay, so that's the number we need to get on. If the results are, if these are results, then what is the difference in the experimental probability from the simulation and the prediction? And I think they mean and the theoretical prediction, or what we predicted here. Okay, so the difference is subtraction, and we need to find the experimental probability. So when we experimented, we did 1, 2, 3, 4, 5 spins. One of them told us that it was going to rain. And from the theoretical prediction, we said that 1 out of 10, or 1/10 chance of rain. So we're going to subtract those. We need them to have a common denominator because we're subtracting. I'm going to change this fraction to 1 with a 10 as a denominator. So that means I'll multiply the bottom and the top by 2. So that's 2/10 minus 1/10. And that equals 1/10. So that is our difference. All right, you guys, if you don't understand this, please make sure you review and maybe watch the videos again. This is a really important lesson. This is where most of your test questions are going to lie, okay? All right, see ya.